David Smith here with one more Flip Classroom Math video. 3 tips before we start. First, realize that you can speed up or slow down the playback if that helps. Second, you could pause the video at any point in time to catch up on your notes. Third, you can turn on the captions and watch my words go by on the bottom of your screen. Today's lesson talks about areas of sectors of circles. So let's take a minute to look at some basic vocabulary for this zone of mathematics so that we can then get on and do some calculating. Okay, here's my circle. Often circles are labeled with the point at the center, so we can call this one circle C. That could be how we would name this circle, okay? Now, basic vocab, the radius is the distance from the center to any point on the circumference. So a circle has an infinite number of radii and they're all the same. In this case, that's equal to r. Now, inside of a circle, we're often concerned with the angle made by 2 different radii. So in this case, that would be theta, and it's just a regular old angle. We also talk about chords, and that will come a little bit later, but a chord of a circle is a portion of the circumference. So in this case, AB is a chord of circle C. Now, this title is area of a sector. Here is the sector. Okay? So that is the portion that we're going to calculate the area for. Now, if you're feeling bold, because you have it, you have the skills, you have the knowledge already, come up with a formula for the area of that sector. Okay, let's see how you did. The area is just, first off, let's take a look. You know the area of a circle is just pi r squared. And so that's right here in my formula. However, I'm doing this theta over 360 thing, so I'm multiplying it by that to get the area of my sector. And that makes sense because theta is a certain portion of 360. So if theta were 90, if I had a 90-degree angle for theta, it would be 90 over 360. And 90 over 360 is 1/4, and 90 degrees would be a quarter of the circle. So it would be a quarter of the circle's area. So it's a real straightforward formula. You just take your theta and you put it over 360. That gives you the fraction of the circle's area that you're dealing with, and then you just multiply this fraction times the area formula for a circle, and you have the area of your sector. One more thing. Often we like to condense things or make them a little bit more simple. So instead of doing it as 1 fraction times this number, I could put the theta on the top and the 360 on the bottom and condense my formula ever so slightly. Either way works. Either way is valid. You'll get all your points from me using either way. Okay, let's do a word problem. So the text that would accompany this problem would be as follows. A circular patch of ground has a lawn that encompasses 120 degrees of that circle. The radius of the circle is 5 meters. What is the area of the lawn? So what we're looking for is the area of this sector. It's a pretty straightforward calculation. So pause the video, do that math, and then come back. Okay, here's my plug-in step. I put 120 for my theta. Pi is pi, r is 5, so 5 squared over 360. Pull out my calculator, crunch the numbers, and I get 26.2 meters squared. All right, let's try that another way. Here's a circle, circle D, with sector CDF. Now we're telling you the area of the sector. So I'll go ahead and shade that for you. We know that that's 30 pi centimeters squared, okay? And it's asking you to find theta. Now before I turn you loose, don't freak out if I'm giving you a number with a pi in it. You could multiply that by 6.28. 30 times 6.28 would give you your centimeters squared, but they give it to you in pi because it's going to be nice. It's going to cancel out and make your calculation easier. So pause the video and do your plug-in step. Okay, so here's my plug-in step. I just did 30 pi for my area. There's nothing wrong with that. That's just as good a number as multiplying it out. And then I have theta, which I don't know, times pi times my r squared. Remember, my r is 13 from my diagram, divided by 360. Okay, if you haven't already done that, rearrange this equation to solve for theta. Okay, I rearranged my equation to solve for theta, move things around, and I have 360 times 30 pi over pi times 13 squared. Now watch this, I'm going to cancel my pi's. I got one on the bottom and one on the top. So now I have 360 times 30 divided by 13 squared. And I don't know about you, but when I get out my calculator, I love to do less steps. So go ahead and crunch that and see what theta equals. Here's what I get, 63.9 degrees. Okay, now let's find the radius. We've used it to find other things, but we can also use it to find the radius. So check it out, r is r, we don't know what that is. We do know that our angle, our theta, is 31 degrees, and we do know that the sector has an area of 567 kilometers squared. So this is a big circle, big sector. So go ahead, pause the video, and do your plug-in step. Okay, here's my plug-in step. 567 equals theta times pi times r squared. We don't know r, so r is just still r squared divided by 360. Now, pause the video and rearrange that equation to solve for r. Okay, here's what I did. I took this equation and I isolated r squared on one side, and I get 567 times 360 over 31 pi. Now that's not r, that's r squared. So I have to take the square root of both sides, and I get r equals this. Now go ahead and pause the video, get out your calculator and crunch those numbers. Let's see what you get. Okay, when I crunch those numbers, I get 2100 rounded to 3 sig figs. The actual answer is a little lower than that, but doing 3 sig figs requires that I go to 2100. Oops, I blew it on that one. Can you figure out my mistake? Go ahead, pause the video, or maybe you already know because you did the calculation like I asked you to. What did I do wrong? Tell me. I forgot to take the square root of that number. If you do that, you get 45.8 kilometers for your radius. Oopsie doopsie. Okay, this one gets more complicated, and the IB is famous for coming up with questions where they ask you to calculate this weird kind of an area for which you really don't have a direct formula. We don't have formulas for calculating the area of a section beneath a chord bounded on the other side by a line that's called a secant line. We don't have that formula. So we're gonna have to do some thinking to find the area of this shaded region. But fortunately, we have all the tools we need to do that. So check this out. My sector is this whole thing. So the area of the shaded region is going to be the area of the sector minus the area of the triangle. And indeed, that's how we're going to go. So what I'd like you to do is just do a general formula. Actually, let me show you what that would be. My area would be area sector minus area triangle, like that. So now I just need to figure out what the area of that triangle is and what the area of that sector is. So check this out. That's 4, so is this. So we already know our sector area formula. We're going to put that up in a minute. And we also know a triangle area formula for this triangle. So this is actually pretty straightforward. Lots of moving steps, a little critical thinking, but ultimately not super complicated. So let's do that. What I'd like you to do is pause the video and write, instead of just the area sector, put the number with a plug-in for that, and then the area triangle formula with all the plugins in the right place for that. Okay, so pause the video, give that a shot. Let's see how you did. So here's the area of the sector. It's just 75 times pi times 4 squared. That's 75 times pi times r squared over 360. That's what we've been working on for this lesson. And then digging back to the area formula for a triangle with sine, it's going to be 1/2 this side times the sine of 75. And indeed, that's what I've got here, 1/2 times 4 times 4 times sine 75. So now I want you to just go ahead and plug and chug and get the answer to this question. Okay, let's see how you did. So I crunch these numbers, I get 10.5 for the area of the sector, and then I get 7.73 for the area of the triangle embedded in that sector. Do my subtraction, and I get the area of my shaded region is 2.77 centimeters squared. Wait a minute, where's the outro? What happened? Thanks for watching. Just before you go, make sure to write down any questions that you have. so that you can bring them to our next class and get them answered. Also, remember that you can watch the video again if you want to deepen your understanding. Finally, if you enjoyed the video, please click like or subscribe.